In this video, we're going to begin our section on solving logarithmic and exponential equations. Now, before we jump into that, let's remember that y is equal to log base a of x is equivalent to the equation a to the y equals x. Now, this is all provided that a is positive and it does not equal 1. Now, this is typically how I look at this. I see it as the log being written first, like this. And what I used to tell my students is I do this thing called flying the plane. I know it sounds kind of weird, cheesy, whatever. So the base of your logarithm, keep this in mind, the base of your logarithm is the base of the exponential. Always remember that. And also remember that the answer to the log is the power of the exponential. So you'll see that the answer to that log gives me that power. So you understand, hopefully now, where everything comes from. Let me show you what I do. Every time I do the problem, this is what I do. I take my base, I circle it, it flies to the y, and it ends up at the x. So I call it flying the plane, doing a loop-de-loop. So that then gives me a raised to the power of y equals x. That's what I do. All right. You may not need to do that, but I don't know, it works out for me, makes me happy. So in math, anytime you can make yourself happy, go for it. So let's look at solving something like this. So log base 5 of 3x plus 7 is equal to 4. So we're trying to solve this equation. First of all, understand it's an equation. When we talk about solving, we're talking about getting the x by itself. Okay. Now x is only in one spot, so it's all about peeling away the layers, right? We recognize we have a logarithm, and we're trying to figure out how do we undo that log. Well, the way we undo it is that we rewrite it from a logarithmic form, like we have here, into an exponential form. So let's fly the plane. So that means 5 to the 4th power is equal to what's inside here. So 5 to the 4th will equal the expression inside, 3x plus 7. All right. So 5 to the 4th, again, you can use the calculator, but we should know 5 to the 4th is 625 equals 3x plus 7. Now, at this point, it's no longer logarithmic. It's not even exponential. It's a linear equation. So solve it like you've solved every other linear equation in your entire life, right? So we subtract the 7, and we have 618 is equal to 3x. Finish getting x by itself by dividing both sides by 3. And we have x is equal to 206. And we're done. No big deal whatsoever. Now, one of the things you need to remember, though, is that when you have something like this, log base a of x, when you have this, x has to be greater than 0. Okay? The domain for a logarithm is 0 to infinity, not including 0. So whatever the expression is inside here, it has to be greater than 0. So for the previous expression that I had, log base 5 of 3x plus 7, when I'm trying to talk about my domain, and especially in terms of solving an equation, the list of possibilities for my solution, it goes back to my domain. So for the domain, this is where 3x plus 7 is greater than 0. So solving this tells me that for any solution that I get, so that I don't mess up the domain for my expression, any solution that I have has to satisfy that. It has to be greater than negative 7/3. Now my answer was 206, so of course that's going to be totally fine. All right. Now coming up, we have this. So if you have log base a of m equal to log base a of n, then the expressions inside would have to be the same. Now, this is, of course, provided that a, m, and n are all greater than 0, and a does not equal 1. So I mean, this is something pretty standard that we see a lot of times. If you have this part, if you have the exact same function on both sides, and they're equal to each other, then the expressions inside would also have to be equal. Okay. Now, this is because, for this guy right here, the log is a one-to-one function. Okay. So it doesn't have with every function, but there are a lot of, like, in the one-to-one functions, it will hold up. So if I do this, if I say log base 7 of 5x plus 1 is equal to log base 7 of 48. Well, since I have the same kind of log on both sides, same base, right, then that means that I should be able to set the expressions inside to be equal to each other. The only way these two logs would be equal is if the expressions inside are the same. So we set 5x plus 1 equal to 48, subtract the 1 to get 47, and divide both sides by 5, and we get 47 over 5. You may be tempted to turn this into a decimal. I would prefer that you don't. And if you were to type your answer into MyMathLab, they typically want you to leave this as a fraction. Very rarely are they going to say turn it into a decimal. But again, just read the instructions so you know what you need to do. Okay, so that one wasn't too bad. Let's see about this one. So 2 times log base 12 of x is equal to log base 12 of 49. All right? So there are a couple of things that we can do here. One of these is to use that property of logarithms that would allow me to put the 2 back up here. Now, if I do that, I end up with log base 12 of x squared. Let's try to avoid ambiguity there, is equal to log base 12 of 49. And now that these logs are the same, we can set their insides equal to each other. So x squared is equal to 49. A nice quadratic equation. What could possibly go wrong? Take the square root of both sides because we just have x in one spot and it's a square. Don't forget the plus or minus. X is equal to plus or minus 7. Now you may be tempted to box this, but you have to remember what your original equation says. We have to make sure that we pay attention to what the original domain is. If I look at this guy right here, the guy that has the variable, in that logarithmic expression, he has restrictions with his domain. And that expression on the inside must be greater than 0. It's got to be it's got to be positive, right? So that means when I look at my two answers, x equals 7 or x equals negative 7, I have to eliminate that guy because I'm not allowed to have a negative answer because it wouldn't satisfy the domain for that logarithmic expression. So the only answer that I have here is x equals 7. Now I do want to caution you about something. We're going to see this later on in some problems. If the problem had started out as log base 12 of x squared equals log base 12 of 49, if the original problem has the square on the inside, then in this case, your domain would have to satisfy x squared being greater than 0, which turns out to be negative infinity to 0, union 0 to infinity. Basically, it'd be everything but 0. So when I do the same work, and I come down to x is equal to plus or minus 7, then all of a sudden both of those would work. And it's the subtle difference between having the original expression with the square on the inside versus having the 2 on the outside and then putting it on the inside. So whenever it comes down to checking your answers, seeing what is valid, you always have to go back to the way the original equation is written, because that will have your restrictions that you have to pay attention to.